Fantastic. So GitHub Copilot. Many of you have heard about this concept and many of you have seen it in action, but there are a few things that are basically interesting about that. One is the technology itself. It's really good when it comes to generating code, when it comes to generating artifacts around the code, helping us out as programmers and designers. But sometimes it's also not that perfect because it's been trained on the large body of code that's been submitted by the open source community in GitHub, and that code doesn't always allow doing things with this, so to say. So the open source community is maybe not designed, or they haven't really done their code in that in the community to let big companies profit on that through releasing tools like GitHub Copilot. There's also another story behind that, which is about the legality of using that code. Of course, when we generate the source code, it belongs to us, we think, but maybe it doesn't exactly. And if it doesn't, what happens from the legal perspective? I mean, are we going to get sued? Is my company losing all its business because somebody has submitted one line of code at GitHub and GitHub Copilot managed to regenerate that code? So those things we are going to actually unveil today and start discussing about problematizing. So as I mentioned before, I have three guests with me. I have Jesper Derehag from Ericsson, who is going to talk in a short while, talk about GitHub Copilot and open source systems. I have also legal Jannice and Merima, who are from the Department of Law from University of Gothenburg. If I understand it correctly, you're actually researching the areas of intellectual property right close to software. So if there is anybody who knows something about this, it's you. You've probably forgotten more than any of us ever knew about the legal aspect of code generation. But I hope that you will help us out to demystify those things. And then I have put together with Jesper, Jannice and Merima half an hour for discussions later on, so that we actually have time for questions and we can problematize that. And I will start a bit with maybe the demo, a bit of food for thought for today. So GitHub Copilot, of course, changes the way we develop software, but the question is if it's for the better or worse. It's for the better because we are faster, but maybe for worse because we lose control of what we actually write and what we actually do with our software design. And then GitHub Copilot generates lots of new code, but how do we really know that it's free from license breach or that it's not even that's even our own code to some extent? And finally, GitHub Copilot has been trained on a large body of source code. So with which respect does this generated source code repeats the same mistakes? I mean, just because something is submitted to GitHub doesn't mean that it's a well-engineered project. Many times we think about Linux kernel being part of the open source community, but there is also a lot of really, really bad code in the open source community. I'm not blaming the community. I'm just saying that GitHub Copilot is used in, for example, university projects or hobby projects, and those are not always a perfect quality. There's always a learning process in those. So I wanted to start up with going directly to showing you three demos. I have recorded videos, so I will play them and I will do a commentary while it plays. There's no sound in the video, so don't worry if you don't hear anything. You should hear me talking about that. But I have three programs to demonstrate you. So one program that's written in a C programming language, where GitHub Copilot basically generates, I would say 90% of the code that I only fill in the blanks somewhere. Then I have a program in Python where there is a function that actually generates some text data, which is a task that is very typical for data science and feature engineering. And there GitHub Copilot also generates basically everything. I'm telling it to what to do. And then a third program where it generates the code, but the code that is being generated is essentially not really usable. I would have to change quite a lot to make it usable. I get a suggestion and I get some ideas, but it's not really what I'm looking for, so to say. So just to start with that. So let me play you the videos. I hope that you can see the screen. That is a video recording. So this is an example of a program where I ask GitHub Copilot to generate something for me. So I write what I want to have. I write that I want to have some standard libraries and get suggestions from GitHub Copilot that I accept. And then I tell it basically to write a function about adding fractions. As you see, I get almost the entire function. I have to write some code, which I'm doing at the moment. But even if I start writing the code, I get a lot of suggestions from GitHub Copilot. Now, even if I want to test that program, I can write a request to Copilot to tell me how to test it. And if I press the button to compile it and to execute it, as you see, I'm getting a result that basically accepted. So in this example, GitHub Copilot has generated almost all the code that I've asked it for. It has generated 99 or 100% of the code, depends on how you look for that. Of course, the idea originated from me, but the code was originated from Copilot. So the question is, who owns this particular product would be a very interesting question to know the answer to. So that's one example. Another example, let me show you the program where it doesn't generate feasible code. Do you see another program now?
Yes, we do.
Perfect. So in this program, I'm asking GitHub Copilot to write a function to connect to CNN.com and save the response in a file. Now, the code looks very nice, and it actually does what I'm asking it for. But the big problem is that this code has been generated to a completely different platform. So I'm using Windows here, Visual Studio 2022 version. But GitHub Copilot has generated the code that is meant for the platform like Linux. So the libraries are different, the way it uses the program is different. The code that it generates looks very nicely, but when I press compile button, it doesn't work like this. There is a lot of different problems. And the big problem, of course, is something that is not written by the compiler, but the big problem is that it has generated the code for a completely different platform. So in order to make it work for my platform, for Windows, I would have to change a lot. Basically, I would have to change maybe 99% of the code. I would have to rewrite everything. I don't think I have actually a program that I've written for that in C, and it doesn't look like that at all. It has to use different methods. So as you see, in this case, I got a suggestion. Maybe I got inspired by this, but I'm definitely not using that in my product later on. And then it comes to the third example, which is a code from in Python, which is a code that demonstrates how to extract features from text. So that's a typical problem that a data scientist solves. If you look at GitHub as a repository of code, there are probably hundreds of these kind of programs that exist there, maybe quite many that are even in books, where those kind of instructions that are written at the moment, they're typical instructions you would see in those books. So libraries that I import, and as you see, all of that is actually being suggested by GitHub Copilot. Not even the code that's executed or interpreted, or those import statements, but even in many cases the actual comments for the code. And if I try to use that a bit more, I try to add new code and I ask interact with GitHub Copilot. It gets smarter and smarter. It understands my style of writing, but I also myself understand my style, GitHub Copilot style of writing a bit more. So as you see here, I'm rewriting the code from GitHub Copilot, but not because it's a bad suggestion, but because the name of the file that I want to read in is different than what GitHub Copilot suggested. And of course, it doesn't know what kind of files I'm using. So it's very good in suggesting. I could do those kind of things. But as you see, in many cases, it actually makes creates code that with a problem. And in this particular case, the problem is that the format of the file that it assumed is different than the format of the file that I actually have. So I could try to fix that code myself, but in order to fix that, the standard tricks probably don't work. So I even have to open up the actual text file and take a look if that format is okay. So here I'm looking at that the separator is actually semicolon, not a dollar sign. And by doing that, I fixed the error. So I got a suggestion from Github Copilot, and I had to fix it. Textually, it was a very small fix. Logically, also not a very big one compared to the suggestion I get. Then, as you see, I could ask it to generate even more text to extract features, and it only knows now, as you see, what's the name of the column. So I could change the name. I don't have to do that. I can only write the name of the code of the new data frame, and even it suggested me here this word count vectorizer. That's a typical library that is used in data science for extracting features from text. So that's not even something that I do myself quite often, but I didn't have to go anywhere. I just got this suggestion from Copilot. Now I could even try something that I was using in other projects. So for example, the TFE IDF vectorizer, right? And as you see, I get suggestions from that quite often. So in a matter of how much time we met, 5 minutes, maybe 7, I'm actually getting a script that's very much usable for my own work and for my own studies. So basically, Github Copilot has generated in those few minutes almost the entire program. And now if even go further and try to use those vectorizers and try to understand what kind of features we want. If I just press tab several times, I can actually get an understanding of what other people have used in connection to these parts of code. So at some point, Github Copilot took over. If I didn't want to, it took over some of the design concepts that I used. So it started to suggest design of my program, what kind of instructions I should have more based on what other people did. So it's no longer my own idea anymore. It starts to get more and more, I start to get more and more ideas, and I start to become more and more like everybody else in the community of data science, using things the way I want. However, as you see, Github Copilot also became much smarter. So it started to use the name of the variables in the same way as I do. So this line which says message equals data frame message, it generated that based on the names of the variables that I used in my own program, which shows that at some point of time, this concept of Github Copilot is really like a co-pilot. It helps me, but I also help it to do that. So we work quite closely together on creating this code and programming. And that is something that I think is one of the areas where I'm very interested how that actually works in reality. Now you see these programs are very simple programs compared to the software that you usually have in industry, in professional programs. But nevertheless, you see how powerful Github Copilot is in generating helper functions. If you could compare that to maybe a junior programmer would Google certain constructs and center solutions quite often. With Github Copilot, you probably don't have to do that. But that doesn't mean that the code has been produced individually by that person. I mean, the code has been co-produced by the Github Copilot. So I think that this demonstration showed you how fast Github Copilot can provide you the code. If I compare myself without maybe you who work with professional software development have a different opinion, but it would probably take me an hour, maybe half an hour to an hour to write this code without Github Copilot. I would have to think a bit more. Now it took me like 5 minutes to have the entire script doing whatever I wanted to. without me going and trying to find the reference of libraries, APIs, or anything on the internet. I basically got that from GitHub Co-Pilot. So that speeds up software development a lot. But the question is at what cost? And then I think I will leave over to Jesper.
Hopefully everybody can see my slides at this point.
Yes.
So first off, I just want to clarify that whatever I'm saying today is really representative of my opinions and not that of my employer at all. So even though we've mentioned Ericsson, this is not a public statement from Ericsson at all. So it's all me to blame for it. But let's start talking then about what actually Codex or Co-Pilot is. So just separating all these terms. So Co-Pilot, I would say, is the product that Microsoft has released. So that's the coding helper that you have as part of Visual Studio Code, or GitHub rather, not Microsoft. Codex is the model that originally powered Co-Pilot. I don't know if that's the case anymore, since it's all proprietary and done inside GitHub or OpenAI. But originally, that model, machine learning model, was called Codex. And so if we look a little bit at the genealogy in terms of what actually Codex does and how it works, is that if we go backwards, so from Codex, that one is based on a model called GPT-3. And GPT-3 is essentially the same thing as GPT-2 from an architectural point of view. The main difference is that GPT-2 kind of defined the architecture, and for GPT-3 they just increased the number of parameters and trained it on lots and lots of more data. And then for Co-Pilot, they again just took the same model, GPT-3, with the same architecture and everything, and just fine-tuned it on code. So in principle and architecturally, Codex is the same thing as GPT-2. There's really no difference. And GPT-2 and 3 are generalized large language models. So they are not specifically tailored for source code in any way. It's just a very large language model. And the way all these three models work is that they're what's called autoregressive models, which just means that given some input, they are trained and are supposed to predict what is the likely next word in a particular sentence. And if that sentence is either natural language or text, or if it's code, doesn't really matter. All it's doing is generating the next plausible word in a particular sequence. And that's really where all the tricks of this is coming from, is that they've separated, not they, but generally how you do it in these language models is that you separate what's called the prompt. So that's the green side here. And that's kind of where we as humans add the text. So in this case, in your previous examples, the green side is kind of where you're adding the comment saying generate this or that. And then you add this prompt character, which is the blue one. And then Codex, what it will do is just, given this sequence of tokens, these sequences of words, it will just generate the next likely word. And in this particular case, the next likely word is an A. And then what it does, it takes that output from the model and then feeds it back into the input. And then it autoregressively, just iteratively keeps generating sequences. And that's really all there is to it. So, and the reason for why I bring this up is that it's very easy to kind of anthropomorphize these models and think that there's some underlying reasoning or some intelligence inside their model itself, or in some sense, that there's some, let's say, innovative thoughts inside the models. There really isn't. It's just kind of a probabilistic model in the sense that it just generates words that are likely given an initial sequence of words. That's all there is to it. We could later on discuss a little bit in terms of like the finer details of how the model works, but I don't think it's really interesting for this particular presentation. But what I really want to talk about here is just emphasize the fact that all it's doing is just generating likely next tokens. There's no magic to it. Somebody's asking in the chat if they should be seeing. Yes, you should see a picture, hopefully. That was part of that slide. I hope, yeah, somebody else saw it, so shouldn't be on my side at least. So anyway, so on a very, very high level, I try to highlight kind of where intellectual property rights may kind of apply for in this setting of machine learning or statistical models or whatever it is. So if we're on a very high level, it doesn't matter if it's GPT-2 or something else. This could just as easily be applied to, let's say, DALL-E, who generates images or whatever it is. It's mostly the same. So usually on the left-hand side, you have some training data. In this case, it happens to be code. And then in the middle, you have the model. And in terms of the model, you could argue that there's actually two parts of IPR. So either you have IPR in terms of the architecture and or the code that is expressing the model itself. And you also have IPR in terms of the parameters or the weights that actually comprises the model of how it's trained. Those things are not necessarily the same thing, so that's kind of why I separated it. And then you also have IPR in terms of the output. So specifically for this case, what I want to talk about in terms of Codex or Copilot is that IPR in terms of its applicability, what's particularly interesting here is specifically training data, because the training data is not only likely copyrighted, it's also licensed in a whole bunch of different variations of licensing in some sense. Also, I will briefly talk a little bit about the weights. So the parameters of this trained model, which is trained on this copyrighted or licensed material. So, and I will go a bit deeper into that. But why I want to talk about the weights is that if we assume that normal licensing applies on the training data, does that mean that the actual is actually derived work based off of the input of the model? So that could mean that some licensing will also be applicable for the weights itself. And then also I want to talk briefly about the output and the probability of, not probability, but the dangers of actually generating copyrighted or licensed code. We had a question in the chat. What do you mean by architecture in slide 3? So architecture here, I mean the architecture of the model itself. So for instance, the GPT-3 or GPT-2 is what's called a decoder only model. So you could have IPR that applies to how the actual architecture look. In certain cases, you have patents that apply to machine learning models, and that usually applies to the model where you have kind of how it looks and how it's kind of tied together, but not how the actual trained model looks. I don't think GPT-2 or 3 is patented, as far as I know, at least. So specifically, patents doesn't really apply in this particular case, but there are other machine learning models that are, their architecture is patented, for instance. Right, and so what makes this kind of controversial then, and again, I want to emphasize that I'm not against, let's say, code completion helpers or utilities or machine learning at all. That's not what the debate is here. Is rather how these models will legally fit together with open source licensing. That's kind of the interesting part, and with copyright in general. And I think that also, of course, applies to DALL-E and all these other generative models. So where am I in time, Wilhelm? I don't remember how. Sorry, not Wilhelm, Miroslav.
It's you're about half time.
Sorry,
you're about half time.
Half time. Okay. So I would need to speed it up. But one interesting where there is an ongoing class action lawsuit where they are representing some of the copyright holders of the data that Git Co-Pilot have presumably been trained on. That's not done yet, but in terms of the actual litigation, so it's an open question, I would say. But with that being said, I want to mention that Co-Pilot has been trained on what's called public GitHub repositories, and they've in a quite a relaxed way just scraped pretty much every public repository and trained it on that. So there's really no structure in terms of looking at what type of license or copyright ownership or anything like that. They've just assumed that everything is fair use. And that's kind of the center of the lawsuit as well, is that GitHub or OpenAI argue that this whole model applies or falls under fair use, while obviously some of the open source community claims that it's not fair use at all, and that it should apply, licenses should apply. That's kind of the short version of it. So to me, this kind of boils down to so what actually is a machine learning model in this particular case? So there are some, including Co-Pilot themselves, that argue that or acknowledge that these large language models are what's a coined phrase of stochastic parrots. So that means that they are essentially just repeating information that they've been exposed to. So parrots means that they're just repeating input that they've already seen, and stochastic is that it's done in a somewhat random fashion. It's not random really, but in some sense, they acknowledge themselves that they do repeat. So you, as a user of this system, you need to be aware of that the generated code could very well be something that has been observed on internet, on a public data set, and could potentially fall under GPL or some other copyleft license, or even just plain copyright even. There are also some people who kind of take this even further and claim that models are a form of learned compression. So some people even argue that it's just a compressed representation of the training data itself. And the way you happen to query that database is just that it's kind of probabilistic in terms of the query language. But in essence, it's just compression. But of course, this is not kind of legally is untested ground, so nobody can really tell what actually is a model in terms of this. GitHub themselves claims that Co-Pilot is essentially a compiler, and a compiler is kind of prior art in the sense that you are allowed to compile, let's say, copyleft licensed code without having some system, the kind of the output of that compiler also being deemed to be derived work of that kind of previous thing. So compilers is fine to use legally, while Co-Pilot in this case, maybe not quite as obvious whether it's a compiler, it's comparable to compiler or not. But that's the argument GitHub is making in this, in their legal stance in any case. So again, are these models stochastic parrots or not? Do they generate previously seen examples? And this is, to me at least, a hilarious example, and it just showcases so many of the dangers with these models that we think they are more clever than they are, but they are just generating usually what they've seen before in some sense or another. But hopefully everybody can see the little video that's here. But there is a very famous algorithm called the fast inverse root algorithm, and that was quite famously published as part of Quake 3. I don't remember what year it was, but quite many years ago. And that was released under GPL2, so that's the GNU public license. But what's interesting here is that all the prompt that they're giving is just writing this fast inverse square root, and then Copilot in this case is just generating verbatim exactly as this has been observed in the training data, including the comments, I should add. So even this, if you see evil floating point, blah blah blah, all that stuff is specifically exactly like it occurs in the real world. So legally, this would be a clear-cut case, I would say. But what's even more scary is that when they kind of go back and start generating the comments for this particular code snippet, the model will actually start to generate a completely different license and a completely different copyright holder. So in essence, it's very easy to think that, well, it's just querying and then we have proper attribution in terms of the copyright. But actually the license is completely different and the copyright owner is completely different. And furthermore, it's just funny as an example is that actually fast inverse square root algorithm is nowadays implemented in pretty much every major architecture. So this code is completely pointless. It should really be replaced by a single assembly instruction, and you don't need to bother with this at all. But still, the model happily tends to do this. But I think, if I'm allowed to kind of hypothesize what actually happens here, is that actually this code is the code that it's generating is not actually the original Quake 3 code, but it's actually the somewhat cleaned up version that you can observe in Wikipedia if you look at it. So if you look up the original release, it looks slightly different, has a few macros here and there. So I mean, from a licensing perspective, it's the same thing, but Wikipedia has kind of edited it to make it more readable in some sense. But what Copilot here is actually repeating is the Wikipedia version and not the GPL-based version. And Copilot supposedly has the system where they will, for any code that it generates, it's supposed to look up if this code exists verbatim in the training data. So Copilot should have found this. But I suspect what happened here actually is that since this is actually the Wikipedia version of this, it's not part of the GitHub data. So this is probably some generated legacy from the GPT-3 based model, which Copilot is actually based on. So I suspect this is actually a bug in some sense. And also in terms of why it actually changes copyright and the license, that's even harder to hypothesize around. It depends on how they build the context, the input prompt to generating the text. So it could be that they're since it's first generating like the function body and everything, and then this person goes back. It could be that the actual implementation goes out of context from how it's done. Plus, also the Wikipedia version doesn't actually have this license header. So it wouldn't be very easy for the model to actually generate this. But in any case, it raises an interesting question from a licensing and a copyright perspective, is that clearly it is repeating text. If you would include this into your code for whatever reason, this is essentially GPL2 licensed code. So if you're really, really unlucky in your own code base, let's say it's some commercial system, it could potentially mean that you need to actually relicense your commercial code into GPL2 and open source it. And if you invested possibly billions of dollars into source code, having to open source it is non-optimal, we could say. So how likely is actually Copilot to generate previously seen code? So they've done some very initial kind of investigations of this and said that in around less than 0.1% of the sampled output does exist in the training set. But if you actually go and look into the details of how they actually measure this, I would argue there's a lot of uncertainty in terms of this measurement, because for one thing, the biggest chunk of like the previously observed sampled outputs that they do, they remove that from when they calculate this 0.1%, because they say that it occurs in so many different repositories online, so that they make that then make the assumption that if it occurs in many places, it's not under license code, it's just general or public domain in some sense, which is strictly not true. So even though it's used in many places, it could still very well be licensed in one way or another. But regardless, it just shifts this number in one direction or another. The gist of it still is that you can't guarantee that the output is not licensed in any way, really, from the output. And basically the way that they guarantee this, or rather basically the way that they deal with this legally, is that they're saying that, well, it's up to the user of the system to actually identify if there is an infringement in this particular case. I don't know how much legally they can rely on that, but in any case, if you're a user of Copilot, you should very much be aware that this is their stance. Right. So quickly, so going back to the legal issues here is fair use versus copyright versus derived work. So they have in their terms of service stated when you kind of upload code to GitHub, you say that you give them allowance in terms of copying that code, making backups, and also parse it into search index or otherwise analyze it in our service. That's in their terms of service. So they, on the one hand, they claim that since they have this in their terms of service, they are in their legal rights to actually use the code to whatever they want. But I would also argue that they should be aware that not all code on GitHub is actually uploaded by the copyright owner itself. Oftentimes it's just mirrors or copies of repos that exist in some other place, and they haven't really at all given they haven't really gotten that approval from the original copyright owner at all. And also this analyze it on our servers is, again, from a legal perspective and looking at the licenses that they're using, since the purpose here is to actually earn money, they want to sell this as a service. We are certainly into a legal gray area, is my interpretation of the situation, at least. So then we're quickly coming into the kind of the other interesting aspects. So for me, really legally, the starting point here is whether it's fair use or not. And I can't really make a judgment of that. I think that's up for the courts to use, but I think worth mentioning is that fair use, the definition of fair use differs quite a lot, I believe, between countries. So they claim fair use in terms of US law. I'm not sure how true that is in other countries. So even though we will have a court decision eventually in the US, I'm not sure how applicable that will be in globally. But if it is deemed fair use, if we kind of reason around it, what does that mean for instance, for copyleft licenses in general? So does that mean that you actually can take any function and write a model that expresses that exact same function, but essentially just being a parameterized version of that same function? So does that mean you can circumvent licenses by just training a model on doing that? That has quite some interesting implications. They are likely quite similar for any copyrighted work, I would say, but still, it's kind of interesting. If it's not deemed to be fair use, then we end up in a very kind of hazy situation in terms of Copilot, how they can or will act. So for one thing, they need to do proper attribution. So essentially saying where did they get this code from, what license does it fall under, etc., etc. This is completely unpublished today. There is no data set. They refuse to tell which repos they've actually used to train the model and so on. So there is essentially zero attribution in this case. They also don't really know what licenses that applies in each individual repo. So even though the most common ones that we know about that are, for instance, copyleft licenses and so on, but there are also other more esoteric licenses that completely prohibit commercial use at all, and so on. So and so far they haven't really kind of separated the even gray area ones to the ones that are very, very restrictive. And again, going back to this, whether it's derived work or not, if the model is derived work, and if they are actually kind of distributing the model or not, that's a big other thing that I don't really have time to go through. But just finally, from an open source developer perspective, I can only mention from my own side is that primarily, I think what most free and open source developers want is just fair attribution. If I've spent hours and hours of doing some work, you really want some form of credit for actually having done that work. I mean, the reason for why we have something open source in the first place is to be able to share it with everyone. Secondly, for some open source developers, having the right to actually modify things is quite important. So when we put code out into the open and we know that somebody is basing their work off of our work, I still want to have the option to be able to take that derivative work and actually modify it again to my own purpose. This is really not the Copilot way is really not conducive in terms of that spirit, I would say, since it's all completely proprietary and hidden and unreleased. And other people also argue that the corporations shouldn't make money, or nobody should make money off of their free work without actually sharing that same work back to the community. That's kind of the spirit of all of it, spirit of all this. And neither OpenAI or Microsoft or GitHub has actually kind of adhered to this in any way, I would say.
Yeah, right. So Yes, first of all, as you see, I'm not in Gothenburg, I'm in Lund, so that's another disclaimer, but I am an alumni from Gothenburg and I did my PhD there. So a lot of my work has circled around the questions of how the information commodity question these boundaries between what is a work, a copy, and what is like general knowledge, which kind of links in exactly to the questions that are of specific interest here, as Jesper was saying, because what that discussion boils down to from a legal point of view is how do we think about the training data? When does it become aggregated knowledge? When is it no longer a string of code that is covered under copyright as a work and is protected as a copy in terms of copyright? So information as a commodity is tricky, and it is tricky because people who use information in their business models, including data, including now training data sets, code, etc., use like a number of layers of information that is being claimed by a number of tools, both by copyright law and patent rights, as we talked about briefly in relation to the kind of the models that can be used to aggregate code, and also by different types of contracts such as licenses. And what happens here in all of these types of models where different types of data sets are being collected from different sources and used is exactly whether this should be considered as something that is like an acquired type of knowledge that is being assembled and put into new use to create new works, or if it should be seen as use of different pieces of code or other kinds of intellectual property protected assets, such as when it's pictures or when it's trademarks or whatever, different kinds of parts that could be in this kind of model. Because if it is, then you can run into the legal problems that Jesper described. Like if we would consider the data as being shared in the exact or compiled and shared in the exact form that it was derived from, then there is a risk that it is just a reproduction of the specific copy. But if you would, for example, compare to what a human would do, or like a coder would do, or programmer, when looking at the different types of codes to learn how to produce new code, then it's something else. Then it's not longer anymore like a reproduction of a code. Then it's a creation of new knowledge, and then you are outside of the copyright protection, because the aim with copyright is to protect only the expression of something and not the ID, or at least that's the kind of theoretical framing. And this is how this is also the rationality that was used in the free software movement, or free and open source software movement, when they wanted code to be protected under copyright, because they wanted only the expression to be protected, not the ID. And interestingly, now they run into the problem on the other side, that since it's only the specific code that is protected and can be licensed under the free open source software licensing regimes, the different ones that exist, then if it's something that is when all these kind of codes that would be licensed under specific license regime would be assembled and turned into new similar information, then they are no longer, cannot claim the derivative work rights that would otherwise keep a software free. So they kind of lose on their own arguments, since they didn't want it to be patentable. Because if it would have been IDs, then it would have been much easier to claim that they would have control over it and could have it also in the next step. So, and this also, I mean, it's not as easy to say that it's protected or not protected, because it also depends on the uniqueness of the code. The more unique the code is, and the more one could not claim that it could be aggregated from different types of knowledge, the easier it would be to identify that it is actually just a reproduction of a code that is put into the machine and then pops out exactly as it is, like in the example that Jesper showed. But if we just think about how it is now with this other what's it called, the ChatGPT, the one that is just now being used everywhere, where people are asking questions to an AI that is producing it as text. Then we can think about that as well, like how if we would take from many different sources and create bigger training data sets, then it's a less chance that it would be actually a copyright infringement. But then the question comes in the next step: how do we deal with this? How do we deal with the kind of creation, and what kind of protection can we award the new creation, maybe? And Merima will talk more about that. So and the fact that the risks that one can take with this, as Jesper also said, and that one can lose a lot of investments, because there could be claims on software as having been covered by licensing, is, I would say, it's a real risk, because we haven't seen this. We haven't seen exactly how these models would be defined in the future and so on. But if it's just repeating, then it's a big risk. But then we can also think about this, how information as a commodity works, and it does not necessarily always work with having the maximum copyright protection or control under intellectual property rights, but there can be layers that are open, and there can be layers that are more closed. As we know, I mean, platform business models, they work with different layers of closure and openness. And that is also, I mean, there's been business model based on open source software, as we know. So it's more like knowing where the risk is and how to attribute the risk, and maybe also consider if then also the kind of proprietary interest is somewhere else. For example, you decrease the time to code something, so then maybe you have like a win in that sense, and you don't need to have it as proprietary in the next step. But that's more of like a business question. So this kind of understanding of where the object starts and ends, and what happens to the next reproduction of the object, is really about trying how easy could it be found, which data that was being mined and how it was being reproduced, and also how much does it take for something to be considered a new work. And as Miroslav also talked about, like the Co-Pilot first, it kind of did more standard things, but then with the training of the specific user, then it can add something, then it adds something else, and it learns something else than the original kind of training data. And then it has become, again, another type of work, possibly, depending on how close it is to the first work. So then the risk again is diminished for something to be considered a copyrightable work in the output. So it's not so easily a clear cut as one could think in terms of law, but it will be probably these discussions that have to come up, and also how to build how to build new systems for detecting copyright infringement will be something that happens just like now when they're discussing how to detect students cheating by the use of AI. There's another model to automate that kind of detection, and that would be something that at least law firms will be interested in trying to have, so that they can help their clients, but probably also have it in-house. So that's like the other way. But it's not certain that it always will be considered a derivative work or an infringement based on what the training data was.
And a detail for what you said when I was trying to get my slides to work is, of course, every time people introduce me as a lawyer, I always say not that kind of lawyer, as in not what you're expecting, but rather than somebody who is an academic and also a legal philosopher thinking about all these things through an kind of like philosophical and academic point of view. So I want to also kind of to invite you to think with us. So Miroslaw, maybe you can go like 2 slides. Yeah, thanks. So what I wanted to do was like, because you said a couple of things in the beginning. First of all, you kind of introduced yourself as somebody who is very optimistic about the technology, and Jesper potentially was somebody who is a bit skeptic about the technology. And this is something that I always talk to my students about, like, are we tech optimists or tech skepticists or pessimist even? And when I do that, I try to raise this question through the very famous case now that I'm sure you're aware of, this so-called Dabus case that has been going the rounds in a number of different jurisdictions globally, where they basically are trying to see whether an AI called Dabus, or named Dabus, that invented an industrial work could be registered as the inventor and patent holder of the invention. Now, this was the question of patents and copyright, and not copyrights that we're discussing here, but on a kind of general level, this is the same question that we have been asking here today. What can something that is not human generate something? And in that case, if a non-human generates something, who owns what has been generated? And in the Dabus case, firstly, they tried this with the EPO, which is European Patent Office, to try to register this patent registration, and went through a number of rounds that you see that I've just outlined here to kind of test, can this invention be deemed as an inventor? And the Board of Appeal in 2021 said in their preliminary view, after having reviewed this, that a patent application must be a person having legal capacity. So they denied this. We can take the next slide. And in a number of jurisdictions around the world, they were trying this as well. So, for instance, in the UK courts, not long after that, they said Dabus is not and cannot be an inventor within the meaning of their Patent Act, simply because Dabus is not a person. And the German Federal Patent Court said exactly the same thing. An inventor must be human. And there were similar judgments that were given in Japan, South Korea, China, and USPTO. And for us legal philosophers, this was actually extremely flabbergasting, because on the one hand, we have been trying to say how law is technologically neutral, how law is open to all these sort of things. And suddenly when we have an artificial creator, we get to the courts of law and they're completely categorical, saying, no, we require an actual human being in order to consider it as a creator, as somebody that has rights. You can take the next slide, please. But there were 2 courts of law that started to open up this reasoning in kind of acknowledging that potentially this is not an object that is something that has been created by a human being, that is owned and controlled by a human being, but that this could potentially be a creating subject. So the Federal Courts of Australia, for instance, said something like this. They said Dabus system can be named as an inventor on a patent application. So it could be named as an inventor, but it couldn't be the owner of the patent. And this was very interesting, but unfortunately this was appealed and then it was reversed in the appellate courts. So even in Australia, they now say, no, it has to be a human being. And also in South Africa, they had a judgment that said Dabu's the invention was autonomously generated by an artificial intelligence, and therefore it could be named as an inventor. And this has not been appealed. The only place in the world where it hasn't been appealed, but it kind of philosophically opens up this possibility of legally acknowledging that something that has been created independently of the human spirit or the human being could potentially legally be seen as also being a subject of law, i.e. something that creates. Can we take the next one, please? So the bottom line that we as lawyers and as legal philosophers are kind of asking ourselves is, can you invent an inventor, or can something that has at one point been invented or thought up by human ingenuity that becomes independent and autonomous to that degree that it's completely independent of the human being, then can it have rights? Next slide. So the Dabu's case was a patent case where they tried this kind of hardware inventor question. Can an inventor invent something that gives rights to hardware? And a similar question was raised now very recently in another case in the American courts. Actually, the same people behind Dabu's also created another AI that could create an artwork of their own, and this is the picture of the artwork that the AI created independently, and they tried to register this as copyright in the U.S. Copyright Office. And the summary judgment just came a couple of days ago, and I haven't really finished reading it all, but it seems now that the US courts seem to open up this idea that they could accept this AI creatorship within copyright law. And they were saying that this is basically like property that creates property. So somebody owns the AI, but then what AI creates might be like some sort of work made for hire that they were also opening up to. Next slide. So in intellectual property law, we have been talking about really a number of different entities that we could say potentially have rights here. So first we have the producers or the teachers that do have rights somehow as copyright holders. We have users that use these sort of works or inventions. They use AI in their own creations in order to create independent work, like for instance, maybe you, Miroslav, were saying. Then what I'm raising here, could the AI or even a robot driven by AI, could they have rights? And could this be something as the kind of like employment rights, or somebody that creates rights as part of their employment, like the US court seemed to be arguing in the Perlmutter case that I've just presented to you. So you have these three potential owners of rights. Click next slide. So legally, what we're thinking of legal philosophically is, okay, can we accept that AI can be a subject, i.e. a creator? If something is created completely independently of human beings, then can it have rights? And there is this very traditional intellectual property rights view that has been kind of upheld everywhere, is only people, Homo sapiens, can have rights. And everything that's created by nature or animals or machines, these are objects and they are not subjects, so they cannot have rights. There is also another traditional view that's kind of very typical of the Western legal systems, but that has kind of been exported globally, and that is this idea that creation happens through a human soul, or a human being is inspired by something or given knowledge about something, and therefore it is also the property of that human being. So we as legal philosophers, we ask ourselves the question, do you need a soul? Do you need to be a human in order to have rights? Because we do have other constructions that are not human beings, but that have rights, for instance, companies. So if companies can have rights, why could we not imagine that these artificial intelligence entities could also potentially have rights. But then there is another kind of issue: is do we want to share rights or even human rights with artificial intelligence? And then the next slide, please. And finally, all courts of law seem to be thinking about everything that is created by and through an artificial intelligence as objects, and we can see this in Davos. But it's still very interesting to see that law is kind of posing very difficult questions, or given difficult questions, because here we see that both software and hardware work together, whereas in law, in copyright and patent law, these are divided. But now we have all these kind of smart objects and smart infrastructures that are infused with data, and where data is producing data, and there are some people and there are some codes, and everything is kind of merged together. So it's very difficult to apply these traditional legal principles that are very kind of based on an industrial society and that require an industrial type of creation, but we obviously are creating and working in completely different ways. And then sort of the last big questions that I want to put out there and I want to open up to you is to kind of not only be asking about these things that we have sort of started asking here, who owns the code, but also kind of the bigger, broader question is, can we share our ownership not just among each other, but also among other entities that may not be human beings? And also, what kind of legal system do we want? I mean, right now we're only talking about very simple licensing, and they can be changed. But for us as legal philosophers, we are more thinking about what kind of human-machine meetings or what kind of laws do we want to have, or what kind of societies do we want to have in the end? So I kind of, on that note, I want to also kind of open up those bigger questions as well, not just who owns the code, but what kind of society do we want to live in? And so we're happy to kind of discuss also those nitty-gritty legal questions as well, but we wanted to also kind of open up to this idea that the society is also changing, and we need to be thinking about that when we're doing these types of inventions as well.